So hi everyone, welcome to Movrsync. Movrsync is my project for the Movement Labs hackathon. So it is basically a DApp that offers a groundbreaking way to trade real-world assets within the Aptos ecosystem through synthetic assets. Our DApp allows users to create synthetic assets for the RWAs in the form of tokens, eliminating the need for direct ownership of the physical assets. On the other hand, it creates an indirect ownership of the physical asset. Like you directly don't own the asset, but you have a token that is directly pegged to the value of that asset. For example, we have three tokens currently: M Bitcoin, M BTC, M ETH, and M Gold, and they are related to, as you can obviously say that, to Bitcoin, Ethereum, and gold, which are the real world assets through to which they are currently pegged. This and our DApp also mirrors the functionality of basic derivatives marking, where you bet on the growth of an asset or whether it will go down. Here also it similarly works like that only. So here you can see the homepage of our DApp. So currently you can see Movrsync transforming real world assets into synthetic treasures for seamless trading. Now let me get started. So let me move on to the next page. So here you can see this is the dashboard, and here on the dashboard you can see this is the dashboard button. You can connect your wallet here. So connecting my wallet, and I will connect my Petra wallet. So here I approve, and my wallet is henceforth connected here. So now let us imagine, like, you want to deposit some amount of Bitcoin, or you want to deposit some amount of your APT tokens and want to get some synthetic tokens. So we go on the deposit. Here you can see your wallet address, and here let me choose because Bitcoin is actually about $60,000, so we have to choose a very little amount of MBTC because it is directly pegged to the token. So you can see that if the approximately value is so I have not chosen MBTC. So you can see if the approximate value is 0.0004, and it comes about to $2.30, and it is approximately 0.37487. So this is the amount of move or APT that we have to deposit in to get this amount of MBTC. And also you can say that this MBT currently does not hold as any real world value, although I have plans to make that possible, and I will be explaining all the structure for these later. So here you can see that, let us currently see that in my Petra wallet I have 0.57 APT. So let us click on deposit. So after I click on deposit, you can see that approve with this, and this function manager is the contract and deposit function is called from that, and this is my address. So you can here click on approve button, and you can here see that. Let me go on my Petra wallet and let me go on my activity. So first of all, like, you can simply see that it was 0.57 earlier and 0.37 has been reduced, and you can see the amount of MBTC that we have received, and obviously MBTC does not have any real world value currently, so this is a very huge amount that we have received. So now moving on, as you had seen that we had deposited the Petra and we had currently spent 0.37 APT and we have 0.2 APT left, and also here you can see that the MBTC has been there. It is approximately $2.3, and currently we have to, as there are not many transactions, this can be updated to the transactions that we have done, and currently I am showing some values here. So moving on, I will be explaining you the architecture and all the challenges we faced, and also here you can see today's PNL represents today's profit or loss. And as the Pith Oracle, I was using the Pith Oracle to get all the real world values, because obviously we are doing RWA tokenization, and obviously I would need or some Oracle. So I was trying to use the Pith Oracle, which was not working properly. It was showing some registry error, and I don't know why. So I am not able to calculate the profit here, but I will be further showing you all the code that I have written, and it just has to be uncommented after the Pith registry is working again. So first of all, I will be explaining you the architecture on the Excalidraw. So here you can see this is the architecture of Movrsync. So let me just take a second, just move it up. So here you can see, first of all, now I will be explaining you the architecture of Movrsync. And here you can see that the user first has to deposit some move or APT that is based on the token he wants. Like if he wants MBTC or METH or MGold, then the value is calculated automatically, and the collateralization ratio is also automatically done. And the move slash APT, as I had shown you in the example, is used. And in the DApp, our contracts handle the deposit, and there are major three contracts: the vault manager for ETH, the vault manager, and the vault manager for gold. These contracts, these handle the deposit and the withdrawal of all the tokens of the move slash APT token, and they also mint back the tokens that we mint, like MBTC or the METH token. And also I have used the Pith as the oracle, which was currently not working, and due to that I was not able to calculate the profit or loss, because I would obviously need a oracle, and I have written the code also. I will be showing you that in a few minutes. And here the move slash APT that we deposit here can be used in our liquidity pools, and our liquidity pools will be further used to back our tokens and giving them a real world value. This is one of the future prospects about my project that I have thought about, that this can be easily done, and I will be trying to doing that. And now moving on to the GitHub repo. Here you can see this is the GitHub repo and explaining Movrsync and the key features about it. And here also I have shown an example about the working, so I will be telling you the example currently. So imagine, like, initially three people have bought tokens, like each of them has bought $10,000 worth of our tokens. Here you can see 10,000 worth of our tokens. Let me zoom in a bit. So yes, $10,000. So each person, the total debt pool will become $30,000, and each person will have 33% of the total debt pool. So this is the initial condition. Now imagine the value of gold doubles. So the value of gold will double and it will become $20,000. So now the total debt pool becomes $40,000. And as each person had a 33% share, he still will have a 33% share. So each person's value will now become, respectively, the MGold user's value will become 13,333, and similarly for all. And as you can see, their contribution in the total debt pool was initially this much, $10,000 each, and now it has changed. So here you can see that the profit of the MGold user will be $6,667, and the MBTC user will have a loss of $43, and the METH user will also have a loss of $333. So you can read more about the example here. And this simply means that according to the total debt pool and the percentage contribution of each user, the profit and loss is calculated. Your profit is also, like, your profit can act as a loss to someone also, and someone's profit can also act as a loss to you. But the benefit of such a derivative market is that they minimize the risk and also minimize the reward. Like here I have written it in a very good language. You will be able to understand here. And now moving on, these are all the main user flow and the working of our project. And here I have mentioned the challenges. The special challenge was the Pith Oracle integration, which was not at all working. So I will be showing you now the code. So this is the code. Here you can see that this is the vault manager that I was mentioning. Here you can go to the sources and see the code that we are using. And this is the code that handles the MBTC value. And here this was the Oracle code, and here I was using Pith, but this code was not at all like compiling, not even compiling and not even publishing. Like it was showing some Pith registry error, so I was not able to use it. But it is very simple to use it further. Like we just have to use it in our deposit modal, and here you can simply uncomment this, and all the oracle will start properly working, and all the assets will be shown. Like here you can see that the profit on loss of the person, it will start showing properly. Here this is the profit term, and here you have to simply replace it with the oracle's values subtracted, as it will come into a vector, and you can get the profit and loss of each person here. So that's it for my project for the Movement Labs hackathon. Thanks a lot.